Good evening, everyone. Today's session, we are going to talk about vSphere, vSAN, and virtual volumes differences first. And once we finish the difference between vSAN and virtual volumes, we can go with the one of the vCenter server feature, which is distributed virtual switch. Okay, so let's start with the differences first. So difference between virtual SAN and virtual volumes, as per our previous session, we already discussed that vSAN and virtual volumes are considered as a software defined data stores. So both are the similar features, software defined only, but there is a slight differences between the both data stores, vSAN data store and vVol data store. Let's observe from this diagram. Let's say if we see the virtual SAN, in our virtual SAN, it is considered as a hypervisor converged software defined storage stack. That means our hypervisor server converged with a local hard disk. Whenever the server combined with hard disk is considered as a hyper converged, or we can say hyper converged infrastructure. If you see in this below, we have three ESXi hosts. Let me open the pointer. We have three ESX hosts, ESX1, ESX2, and ESX3. These three ESX hosts, each host have a multiple hard drives, one SSD disk and two HDD. Similarly for ESX2 and ESX3. When the server is having a server with the storage combination, this combination is considered as a hypervisor converged software defined storage stack. So using these three ESXi host local hard disk, in our previous session, we configured a virtual SAN. So that is the importance of virtual SAN. When it comes to the virtual volumes, here it's not about the local hard disk. We required a external storage arrays. So this external storage arrays can be a sandbox storage area network, or it can be a network attached storage. But how we can access the vVols is we can access mainly using the VASA provider. VASA provider will provide a API call. API means application program interface. Using API only, we can create a virtual volume data store, and virtual volumes will communicate to the external arrays. So that means it's considered as a external storage app centric automation. That means application related automation. And but when it comes to vSAN, it's like a hyper converged infrastructure SAN. And the additional differences are, in our virtual SAN, radically simple hypervisor converges storage for virtual machine. When it comes to virtual volumes, it is mainly a management integration framework for external storage. And in our virtual SWAN, we have a two types of architecture, all flash architecture and hybrid architecture. If it is a all flash architecture means instead of SSD and HDD, we can maintain all the all flash hard drives, all SSD disk we can use. And the speed of the and increasing the scalability is 2 times greater scalability. And if we are using a all flash, it will be a 4 times greater. And the performance wise, if we use hybrid, it will be a 2 times performance, 2 times higher performance. And the hybrid means we have a different types of hard drives. Capacity tier is SSD, and a cache tier is SSD, and capacity tier is HDD. And virtual SAN will also support to create a virtual machine snapshots and clones. And similarly, in our virtual SAN also, the main only difference is it uses a native array capability. Array means our external storage arrays. And VM level operations, we can provide a storage profiles directly on a virtual machine level. This option is available only in a software defined storage. It's not available on a FC SAN, Esxi SAN, and NAS storage. FC SAN, NAS, and Esxi are the only predefined storage boxes. At a time, we can apply only one policy. Whenever the customer requested for a multiple storage profile, different type of policies, that option is possible only with a virtual SAN and vVols. From this diagram, we observe the main differences between vSAN and virtual volume. And the next slide, I will show you what is the common features available in both vSAN and virtual volumes. One common point is both are the software defined storages, and it will both are supported for a storage policy based management. So common policy driven control for virtual SAN, and virtual volumes. So the policies here, the benefit of storage policies are storage policy management experience and per virtual machine granular management, and it will also support for storage vMotion for non-destructive migrations and vSphere replication. That means mainly for disaster recovery and high availability, and also it will also support for a Vrealize suite automation. Even if you want to integrate with our vSAN and virtual volume data stores to any automation tool, Vrealize automation also supported to do the automation via REST API calls. And not only automation, we can also, if we have any repeated task, all the repeated tasks can be automated using orchestration workflows. And we can also monitor our data store status continuously. Okay, to monitor the vSAN and virtual volume data stores, normally we use from the Vrealize suite, we can use the product name called Vrealize Operations Manager. This operation manager will help you to monitor all our vSAN data store and virtual volume data store. Because suppose we created one vSAN data store and one virtual volume data store. In future, customer is creating a multiple virtual machines on both data store. At certain time, maybe after 6 months or after 1 year, the data store is all of the sudden full. So daily we will be busy with some day-to-day operations. We will not monitor frequently for data store. During that scenario, if you use a vRealize operation manager, if you configure a one alert monitoring for the vSAN and virtual volume, it will help you whenever the data storage consumes over 80% or it consumes over 90%, immediately it will send a notification alert says that our vSAN or virtual volume data store is full. So that time our vSphere administrator will log into the vCenter and he will try to do some cleanup, or we can say housekeeping on our data stores. How we can do the housekeeping is by clearing the unused virtual machines, or if there is any old virtual machine, you can remove those old virtual machine. And is there any external ISO files or old snapshots, we can clean up that and we'll get some free space on our vSAN and virtual volume data store. But some situations, if there is no free space, we tried all the possibilities like removing the old old virtual machine, the old ISO files and folders. Final option will be, if there is still the data storage are over 80%, only the recommended solution is we have to extend our data store. Let's say our data store size is 4 TB. You can increase your data store size from 4 TB to any additional 1 TB or 2 TB. Okay, depends on our available data store size. If it is a vSAN, if you want to increase your data store, only option is we need to add a new ESXi host. When you add a new ESXi host, your host will comes with a local hard drives. Using the local when we add a new host, it will get the additional disk. That disk will be combined to vSAN. But when comes to the NAS virtual volume, definitely there will be a multiple storage array. One array is full, you can use the additional space from the another array. Okay, that's how we can maintain the monitoring whenever it's triggered any alerts. Also, our vSphere administration portion is we have to resolve the alert either by housekeeping the data store size, or the final solution will be increase or extend your data store space. Okay, so this is about the main differences between our software defined data stores, vSAN and virtual volumes. Now today we are going to start the another vCenter server feature. The feature is distributed virtual switch. In our previous sessions, we discussed about the ESXi host networking. During the ESXi host networking, we talked about only the standard virtual switch creation. But the standard virtual switch is only the ESXi level feature. But when it comes to distributed virtual switch, it is a vCenter feature. You can create a distributed vSwitch in data center level. So let's observe the same what type of virtual switches are available in our vSphere environment. We'll quickly recall this point. Hope you remember these types of virtual switches. Let's quickly discuss this point. A virtual network supports standard and distributed switches. So our vSphere network have two types of switches. One is standard, another one is distributed switches. Both switch types are elastic. Elastic means it's a flexible. We no need to take care of the ports increase, decrease and all. Every time whenever the ports are full, but automatically virtual switch or DV switch will take care of port increase, port decrease options. Okay, that's why we call it as both switch types are elastic. means flexible. Ports created and removed automatically. Okay. And how many maximum ports and all we discussed in our previous session. If you open the VMware configuration guide, you will find virtual switch how many ports and distributed switch maximum how many ports it supports. Suppose today's session distributed switch. Distributed switch, it supports the maximum ports are 60,000 ports. So 60,000 ports, entire vCenter we can utilize. Okay. And the standard switch means virtual switch that configured for a single host. But when comes to distributed switch, virtual switch that is configured for an entire data center. So entire data center means vCenter server, we know how to create a data center. For one data center, you can create one distributed switch minimally, and maximum you can create a multiple distributed virtual switches as well. Okay. And one distributed vSwitch up to 2000 hosts can be attached. Okay. We can add maximum 2000 ESXi host per one distributed virtual switch. That is the configuration maximum. And the configuration is consistent. Consistent means it's a permanent for all across all attached host. Consistent, or we can say reliable. So whatever the configuration we have in our distributed virtual switch, the same configuration will be applicable for all associated 2000 ESX host. But in our home lab, we just added a minimum 3 hosts. But the same configuration is applicable for whatever the additional host we added in future. All configuration is consistent for all the attached ESXi hosts. Okay. And the host must either have an enterprise plus license or belongs to a vSAN cluster. This is the important point. In our vSphere environment, we have a multiple types of licenses like a standard, advanced, enterprise, enterprise plus. We verified these license types while downloading the ISO file from VMware website. When you are downloading the ISO file, you can see multiple license types. This vSphere switch is one of the vCenter advanced feature. This feature is available only with a enterprise plus license. That is the first method. And the VMware also say there is a second method. If you have a license for virtual SAN cluster license, even a virtual SAN cluster license also comes with a DV switch feature. So any one license is required to configure a distributed switch. But in our home lab, we are using a evaluation period. So evaluation means by default, it will, this advanced features also, it will support until the 60 days grace period. Okay. Now we'll quickly observe the architectural differences between standard virtual switch and distributed virtual switch. uh, let's discuss about the standard virtual switch. If you recall our previous sessions, we have in this diagram, we have a 3 ESXi host, and each ESXi host must come with a default one virtual switch. So this is a gear icon. Gear icon means it's a configuration symbol. So each ESXi host, we have to configure one virtual switch by default. Using the virtual switch, we can communicate between all our virtual machines. That is the purpose of virtual switch. It's the same like our normal network device physical switch, how it will allows the communication between two or more devices. Similarly, for our virtual machines also, if you want to communicate from one VM to another VM or one VM to any external network, our main communication mediator is virtual switch only. And this virtual switch is help you to communicate within the ESXi host VMs. It will also help you to communicate to the another host virtual machines. So same way, second ESX also we have another vSwitch. Third ESX also we have a vSwitch. This is the default architecture for our standard virtual switch. But if you compare the distributed virtual switch, the name itself, we have a distributed virtual switch. That means for this 3 ESXi host, we have 3 virtual switches. But if you want to configure a distributed virtual switch, the best option is first we need to add this 3SX host to vCenter server. When we add the vCenter server, you no need to create a 3 virtual switches. You can create one DV switch. That DV switch will support for all these 3 hosts. Let's observe from the next slide. See, this is the distributed virtual switch architecture. So DV switch in short form, we call it as DVS, or we can say VDS. Any name we can use, don't confuse. DVS means distributed virtual switch. VDS means vSphere distributed switch. Any name we can use. Sometimes some of the VMware articles, some they represent as DVS, some represent as a VDS, but both are same. Okay, so you can use any name, VDS or DVS, anything is okay, same meaning. If you see in the compared to previous diagram, and here we have three virtual switches, but when comes to DV switch, we have only one switch. And the configuration also very simple. Just add the three SX hosts and configure only one DV switch. But it's not only for three hosts. How many hosts we can add in our DV switch? We can add maximum 2000 hosts. So for 2000 hosts also, the configuration is only one time configuration. So this is the high level overview of DV switch architecture. In our next slide, I will explain in detail what is the in detail of DV switch architecture. Suppose here we have only one DV. We'll take the one of the configuration scenario. Let's say virtual network configuration scenario. I took the example of two example. First scenario is one virtual switch. Second scenario is we have a DV switch. So in our virtual switch scenario, let's say ESXi host count is 300 ESX host. When we have a 300 ESX host, if we want to configure virtual network configuration, normally what is the recommended configuration is I given the example of 5 network configurations. Let's say in our standard switch creation, we have to create every host must should create a VM kernel port group for management, host management, and another VM kernel port group for vMotion purpose, and another VM kernel port group for storage access. In our previous sessions, during the storage session, we observed how to create a VM kernel port group. For which storage we required VM kernel is, it will if you want to access Esxi SAN storage or NFS storage, we have to create a one VM kernel port group. And also we require a VM network port groups. VM network port groups, I created two VM network port groups here. I mentioned two. One is for production VMs, one VM network port group for test and development VMs. This configuration is recommended for one ESXi host, and it's not limited to 5 port groups. You can create more than 5 port groups also, but minimally we required all these 5 port groups for each ESXi host. Let's say if I want to configure these 5 port groups, roughly I took the time consumption per host is 15 minutes. If I want to configure for 300 ESXi hosts, what is the overall configuration time? Just multiply by 15 into 300 hosts. The configuration time is 4500 minutes. So 4500 minutes means if you divide with the 60, that means 60 minutes, you will get the how many hours is close to 75 hours of task. If your environment is large organization, if you are using a 300 ESXi host, if you want to do a manual task for a network configuration, we have to spend 75 hours to configure this task. So to address this situation, there is a multiple options are available. One of the best option here is distributed vSwitch, and once we discuss the DV switch, I will explain the what is the any additional options also we can discuss. Suppose if you the same scenario, that same 300 ESXi host and the distributed virtual switch creation and port groups are same. If we have a same port group, but DV switch, we no need to spend our time for a 75 hours. Even within 15 minutes, we can create the port group, and this all port groups is associated to all hosts. That same point we highlighted here. See, the configuration is consistent across all attached hosts. Whatever the configuration we configured, the same network is applicable for all your 300 ESX hosts. That means we no need to create the vSwitch and virtual switch and port group configuration 300 times. We can just configure one time, 15 minutes time spent, and overall configuration also we can finish less than 15 minutes. And what is the benefit of DV switch is DV switch saves time and presents a more efficient management construct by eliminating per host configuration. So this is the main use case why we go for a distributed virtual switch. Even this is an important interview question, and sometimes you may get the most of the VMware certified professional exams. You will get minimally few questions on distributed virtual switch. Okay, so the key point here for distributed virtual switch use cases, it's mainly for to save time and also for efficient management and by eliminating the per host configurations. Okay, suppose there are some external options also available. Let's say we do not have a DV switch, we do not have a enterprise plus license or vSAN cluster license. Because if you want to do a DV switch, our main condition here is we must and should have a enterprise plus license and vSAN cluster license. For example, one of our customer, let's say they do not have a enterprise plus license and also they do not have a vSAN cluster license. But during that scenario, still if we have a 300 ESX host, we no need to spend for a 75 hours. There are some additional options also available, but that additional options are only for a one-time job only. Like we can use command line using VMware Power CLI. Power CLI is it's like a Windows, we have PowerShell. Same way in VMware also we have a Power CLI option. Power CLI means command line interface. Using Power CLI, we can prepare some script. Using the script also, we can create all the port groups on our associated 300 ESXi host. But the script also only one time we can do. But if you want to manage all the ESXi hosts, if there is any one minor change, let's say the production port group name, we want to change the name to any different name, like a production port group, you want to change to the production plus mission critical. If you want to rename also, 300 times we have to log into each host and select the host particular port group we have to rename. That means again we have to prepare a new script to do the renaming. So even the script also there will be some challenges and we have to spend some extra time to prepare a script. But the script will help you to reduce your manual effort time. That is the one external option. But the most recommended option from VMware is if you buy a virtual vSphere Enterprise Plus license or vSAN cluster license, our manual task time will be reduced, and not only the manual task options, even we will get a easy efficient management. That means in our distributed switch there will be some additional features also available. Like if you want to take your DV switch configuration backup, we can take the configuration backup, and if you want to monitor the DV switch, we can monitor. But the vSwitch monitoring options are not available in our standard virtual switch. That option available in a vSwitch, DV switch. Not only these features, there will be some additional features I will show you in the following slides. Okay. So if you have any questions here, let me know, because this is a very important point. Clear?
Yes.
Okay. Okay. Good. Now we'll talk about the virtual distributed switch overview. Okay. So in our vSphere distributed switch, the main in these slides, what I mentioned, the same points. There is a one key feature is network health check we can do, and also vSphere distributed switch configuration backup and restore. We can take the backup of our DV switch configuration whenever any DV switch level issue. If we have the backup, we can restore from the existing backup, and also management network rollback and recovery. Even if there is any management network means our VM kernel ESX host management. If there is any discrepancy in our ESX host management network also, we can roll back the changes and we can recover also. Okay, that options are available in distributed virtual switch. Not only these three, there will be some additional features like net flow. Net flow means network flow monitoring. Even if you want to monitor from your virtual switch one port to another destination port, you want to verify the entire the port flow monitoring. That using the net flow feature, we can do the packet capturing and also monitor our source to destination virtual machine traffic. And also there is an additional feature that is called port mirroring. The name itself says mirroring. Mirroring means we already heard this word from RAID 1 feature. RAID 1 is a disk mirroring feature, but here is a port mirroring. Port mirroring means, let's say we have a virtual switch, one VM is using one NIC code, means it have a one virtual port. That port, if you want to do a port mirroring feature, when you enable a port mirroring, it will duplicate another port, and the duplicate port, it will analyze the traffic flow. Okay, it's like a same net flow is it will monitor the existing port, but port mirroring is it will prepare a duplicate copy. That duplicate port, it will generate the traffic and it will verify the work flow, how the traffic is moving from source to destination. and SNMP. As I mentioned, our DV switch have a monitoring facility. If you want to monitor, you can monitor either a normal ping monitor or you can use a SNMP service. SNMP full form is Simple Network Management Protocol. This protocol is usually used for monitoring our devices. Its device means either a ESX host, vCenter server, or DV switch. Okay, let's understand the main points. vSphere distributed switch is the enhanced version of virtual switch. Just now we observed obviously it's a enhanced version of virtual switch and can be configured and centrally managed from vCenter only. Okay, this is feature is not available in a single host. And VMware vCenter server maintains the configuration of the vSphere distributed switch. So only vCenter only maintain the entire VDS configuration. The configuration is consistent across all the hosts that use it. Okay, and we can configure virtual machine port group, VM kernel port group. We are familiar for this point. In our virtual switch also we have only two types of port groups. One port group is VM network port group, another port group is VM kernel port group. Even the DV switch also have a only these two types of port groups. There is no any additional port group. But only difference is VM port group is mainly for virtual machines traffic and VM kernel port group for ESXi host management, and it will also provide some additional services. What is those services are vMotion, storage traffic, and also there are some additional features are available in VM kernel port group. Okay, so port group wise concept is same in vSwitch and DV switch. And a vSphere distributed switch enhances the use of NICs, because in our suppose in our virtual physical NIC, if you have a same speed like 10 Gbps, the same speed 10 Gbps, and it will be faster to the DV switch level. Suppose in the vSwitch level scenario, sometimes there is a chances of slightly reducing the speed, but in the DV switch, it will enhance the speed of our network card speed. Okay, normally VMware recommended network speed is minimum is 1 Gbps and recommended speed is 10 Gbps. Even if your environment is if you are maintaining a very critical applications, you can use the more than 10 Gbps speed also. Okay, and the behavior of DV switch is consistent with standard switches. Even if your environment is using any standard switches also, the same configuration and also the communication wise, there will be no impact. You can use within vCenter server, you can free to use vSwitch and dvSwitch both. Okay, the configuration wise, no issues. And it is also enable a software defined network. This is the important point. This VDS will also help you to configure NSXT environment. NSXT is a one of the software defined network product, and previously we have a NSXV. NSXV means it's supported only for NSX vSphere environment, but recently VMware launched the latest product, that is NSXT. T means transformers. This NSXT not only for vSphere, it will also support for private cloud, public cloud, multi-cloud. Anywhere you can use NSXT product. So mostly in future, the NSXT will be the one of the popular network virtualization product. Already it's the most popular. In future, we may expect there will be a more popularity for NSXT, because NSXT is not dedicatedly for vSphere. We can use anywhere. Anywhere, if you want to implement the software defined network, we can use NSXT. And our DV switch is also compatible with our NSXT configurations. Okay, and again, if you are using DV switch in NSXT environment, our main purpose of DV switch is reducing the operational efforts. Okay, because it's a distributed switch, all your task will be reducing the operational efforts and delivering greater agility. Agility means speed. Any task we can do it very fast using distributed switch. Okay, and now we already have some idea on benefit of DV switch. Let's talk about some more additional benefits of distributed switch. So benefits of distributed switch: simplify data center administration. So we already see the example how it will simplify the administration task, and provide support for advanced features such as private VLAN. So private VLAN means, normally we know in during our networking concept we discussed what is VLAN. Normally if you have a one VLAN like 32 port switch. We have a 32 port switch. All the 32 ports are assigned for one LAN, one local area network. Within the LAN, if you divide it into a multiple groups, like 32 ports, you divide it into a 4 8s. Let's say 8 ports are one LAN, one VLAN, another port. When we divide one LAN into the multiple group, that is nothing but a virtual LAN. But a private VLAN means it's a private VLAN is mainly for a isolation purpose. So that means our ESXi host, I don't want to connect any of the external system. I don't want to connect by any external world. Even my host details it should not be revealed to the any external world. During that scenario, we can configure private VLAN. It will be dedicated. It's completely isolation, separated network. So this is I will show you in today's lab how to configure a private VLAN. This is also one of the important feature in vSwitch. And there will be a net flow. We discussed it's for a flow monitoring, and there is advanced monitoring is port mirroring, and enable the networking statistics and policies to migrate. See the word policies, we are familiar. We discussed in our storage level policies, SPBM, storage policy based management. Similarly, in our network level also we have policies. Anyone remember the vSwitch security policies? What is the vSwitch security policies?
Promiscuous mode for the transmit and MAC address changes.
Yeah, very good. Same way, whatever we have the policies in our vSwitch, the same policies applicable in a dvSwitch also. Okay, and these policies will always help you to migrate the virtual machine during the migration with vMotion. Let me elaborate this point again. Normally, vMotion means it's a live migration, moving the virtual machine from one ESXi host to another ESXi host. If you want to migrate a live virtual machine from one host to another host, the main condition from the vMotion feature is we required a shared storage. Shared storage means you can use FCSAN, Esxi vSAN virtual volumes. But this point, what it is saying is enable network statistics and policies to migrate virtual machine during a migration with vMotion. That means even though if you do not have a shared storage also, network level migration is available if you are using a distributed switch. That is the importance of this point. I repeat, if you have a standard switch, if you want to migrate a live virtual machine without shared storage, it won't possible. But if you have a distributed switch, if you want to migrate a virtual machine from one host to another host without a shared storage device also, we can migrate. That is a point we are highlighting here. Okay. And another point, provide for customization and third party deployment. Third party development means suppose if you have any external switches, even those external switches communication also, if you want to communicate through DV switch, we have a facility to use API calls. Using the API, we can also use the customization in our DV switch level, and it will also supported for your third party products, not only dedicated for vSwitch vSphere environment. Okay, and similarly, there are some additional benefits like bandwidth level changes we can do, and we can use the NICs and NIC teaming. NIC teaming means it will help you for bandwidth and also the redundancy. It will provide a redundancy. Whenever one NIC is down, immediately standby NIC card will activate as a active adapter. Okay, and also there will be some additional protocol facilities available. Normally in our vSwitch level, we verified one of the protocol is CDP, Cisco Discovery Protocol. Similarly, along with the CDP, in our distributed switch, there is a additional protocol support that is called LACP. LACP full form is Link Aggregation Control Protocol. So this is also one of the important point. In the next slide, I will show you what is the importance of LACP. Okay, and the distributed switch, there will be some more additional features like private VLAN support. We mentioned here private VLAN support, and also third party virtual switch extension support. If you have any third party virtual switch means you can use hypervisor, Microsoft hypervisor virtual switch, or you can use Xen server virtual switch or Oracle KVM virtual switches. Third party virtual switches also, it will support to communicate using the API call. Okay, and another point is maintain network runtime state. Always it will maintain a runtime for our entire distributed virtual switch networks. Okay, so now we'll try to understand the how we can configure a distributed virtual switch. Some more in detail. So virtual network configuration scenario. As we know, by default, if you want to configure a DV switch, the main key point is we require a vCenter server. Let's say this one is referred as a virtual center server. The virtual center server main purpose is to manage multiple hosts. So in this diagram, I took a 2 ESX host. Host 1 and host 2, and this ESXi host 1, it have a 3 physical NICs, and host 2 also have a 3 physical NICs. So when we have a 3 physical NICs, we call it as it's a physical environment, and the physical NICs we can also, in our virtualization environment, physical NICs also call it as a uplink. Okay, the terminology is uplink. In our whatever the communication in our top of the physical layer, we consider as a virtual layer. Within the virtual layer, vCenter is connected with the 2 hosts, and it have a 6 physical adapter. And using the, whenever we add this host to vCenter, then we can create a multiple virtual machine. Just for our easy understanding, I took the 4 virtual machines are created. Now let's talk about the DV switch configuration scenario first. Before creating the distributed vSwitch, in our ESXi host, whenever we create a distributed switch, underlying there will be a one hidden virtual switch will be created. But by normally when we see from graphical mode, we cannot see. But when we create a distributed vSwitch, each host will have a hidden virtual switch. But how it is distributing the traffic means the backend scenario is hidden virtual switch, or we can call it as a every ESXi host have a host proxy switch, but it is not visible in our graphical console. But in the backend, by default, the backend it will run in a each ESXi host level. Okay, this is the main intelligence of distributed switch, and it will maintain the input output plane. Okay, now if we create a distributed switch in vCenter level, so as we discuss within the distributed vSwitch, this is the main control plane. We have a 60K ports it will support. The limitation configuration limit for the distributed vSwitch is it will support up to 60,000 ports. Okay, and whatever the physical adapters we have, the same physical adapters will applicable to DV switch also. Let's say we call it as a uplink port groups. Using these uplinks only, we can configure a multiple port groups. But if you want to create a multiple port groups, we no need to bother about the ports count, because virtually ports increase, ports decrease, port removal and all the intelligence will take care by distributed vSwitch virtually. We no need to bother. But to just understand that DV switch have a capability to create maximum of 60,000 ports, and even the vCenter server limitation also. Each vCenter server it will support for a DV switch ports up to 60,000. That means within your vCenter, even though if you create a multiple DV switches also, but the overall active ports vCenter it supports up to 60K only. That means this 60K you can either maintain a one single DV switch, or suppose if you divide it into 6 DV switches. If you create 6 DV switches means each DV switch you can limit for a 10K ports, 10,000 ports per all 6 DV switches. That means 6 into 10, it's again we can reach the limit 60K thousand of ports, 60,000 of ports. Okay. Now we have the idea of DV switch, and even DV switch physical connection is whatever we have the physical NICs, same NICs are comes to the DV switch also. Let's talk about the port group now. We know the port group also DV switch have a 2 port groups only. One is for VM kernel, another one is for VM network. So let's create a first ESXi host. We created a one port group. That port group also we assigned one port only. Port means because management port have a VMK adapter IP address. So it's dedicated for only one port. So we have one management port assigned, and the distributed ports also, how many port groups we can create in DV switches as per configuration maximum guide. It supports maximum port groups are 10K port groups. So just now I created one port group. Within the port group, I used management port. Same way for host 2. Even the to manage our ESX host 2, we require a one management port to access our ESX host 2. Okay. And not only management port, even we also require a virtual machine network ports. So we created a VM network port groups. VM network also, each virtual machine network card, it will connect to VM network port group, and even the another VM also connect to VM network port group. This why we may mention two port groups, sir. Maybe one is connected to test port group, one is connected to production port group. And this NIC cards virtually, we have a 10K ports. So I just mentioned one spare port. Even if you want to add multiple NICs to virtual machine also, we have facility to add multiple NICs. We already tested this lab in our vSwitch lab. One virtual machine, you can add not limited to one NIC, you can add multiple NICs. Okay, and this is about the virtual machine network connection and this connection for VM kernel connection. Not only this, even our ESXi host level, there is some additional services like vMotion, storage access, and also the vSAN. All also required a VM kernel port group. Let's say I created additional two port group, one for a vMotion and one for a vMotion. This vMotion port group, why I mentioned the two port group is normally DV switch one port group is enough. Suppose if you are using any different network scenarios, like one network is let's say production network, we require one production network vMotion port group, and for the test V network we require a different test network port group. So these all port groups are one-time creation is enough. That one-time creation will support for a all the associated ESX host. Let's say we have ESX1, ESX2. In future, if I add another ESX also, these port groups are no need to create again. The existing port group we can use for a newly added ESXi host. This is how we can configure in a distributed virtual switch. It's almost same like vSwitch only, but only difference is we are configuring in a vCenter level. That is only the different. Okay, and the main key points I just highlighted again. Ports for a distributed switch is 60K, and a distributed virtual network switch ports per vCenter. Even vCenter maximum also 60K. That means even if you create a multiple DV switches, you can just keep an eye on ports usage also. And the static and dynamic ports. Static means by default every DV switch comes with one DV port group, either a static port or dynamic. Dynamic means automatic. Static means manually created port group. Either manual created or automatic port group. Per vCenter, we can create the maximum port groups are 10K. So 10K port groups only we can create. Clear? Now we can talk about the this manage control plane and management plane. Control plane is taken care by DV switch, and even the management plane taken care by our management port. Most of the time our management plane is mainly on a vCenter level. These points will discuss some more detail in the following slide. So this is the official diagram from the VMware website. So if you see here, let's say in our physical environment, until now previous slide we talk about only the virtual area. Now I just elaborated the physical area also. So in our physical environment, I just mentioned physical switch. That means it's not limited to one. There will be a multiple physical switches here. So within the physical switch, we have a multiple LAN ports. These LAN ports are connected to host 1 and host 2. Same like previous diagram, our host 1 have a 3 NIC cards. But in the ESX level, NIC card name is VMNIC 0, VMNIC 1, VMNIC 2. Same name for host 2 also, and this considered as a physical, excuse me. In the physical network, we have this connectivity. Hope this connectivity and all, we no need to worry. Our network administrator will take care of this connectivity. Our job is only the virtual layer. Within the virtual layer, just now we discussed uplink port group. We can create a port group using the physical links only. We can create the port group, but there will be one hidden network plane, right? That is considered as a host to proxy switch. But normally in the graphical mode, we cannot see, but the underlying concept inside is host to proxy switch. Every host will maintain. Even the host to also have a host proxy switch. And within the host, it will support for a two type of connections. One connection is production network, one connection for VM kernel. VM kernel mainly for management and ESXi host services. Production network mainly for virtual machine communication. So same type is available in host 2. This is considered as a data plane. Now come to the management plane. Management plane means we can manage only from vCenter server. Within the vCenter server, you can create one DV switch or you can create a multiple DV switches, and each DV switch you can configure a distributed port groups. So in this diagram, we have uplink 1, uplink 2 port group, uplink 3 port group. Port group means grouping of multiple ports. Okay. So one for virtual machine traffic, one for a management network. So same points I highlighted here. vSphere vSwitch separates the data plane and management plane. So management plane is above one, data plane means below one. Okay, and the management functionality of distributed switch resides on the vCenter server system that lets administrator the networking configuration of our environment on a data center level. So within our vCenter data center level only, we will take care of the all the management, and data planes remains locally on every host that is associated with distributed switch. So this one we no need to configure anything. When you add the host to vCenter, this host proxy switch and all, it will create automatically. Okay, so data plane section of distributed switch is called host proxy switching. Okay, and the network configuration that we create on vCenter server is automatically pushed down all host proxy switches. So it will automatically created. Okay, same point I've written here. And now we'll talk about the usage model. See, this is the usage model. So usage model is within the distributed vSwitch, we can create mainly two port groups, one for a VM kernel, one for a production network. The same thing, points I just highlighted here, how we can divide. Uplinks also, even uplinks also, let's say one usage here, one key point is our management port group, one NIC cord connected to one switch and another NIC cord connected to another switch. Why we need to connect it to two different switches? What is the benefit of using a multi connection, multi path connection? The benefit of multipathing is for load balancing and also the failover. In case of one network path connection is down, immediately our access will be communicated from another switch. Okay, so we create a distributed switch named VDS01, and we can create port group production, which will be used for virtual machine networking, and uplinks VMNIC1 connected to host 1 and vMNIC1 on host 2 connected to distributed switch. So when we have each ESXi host, must and required one network card dedicated for a management traffic. Okay, and from each ESXi host, two NIC cards minimally we can use, and you can use more than two NICs also. That is the main importance of usage model. And we set up a distributed switch on vCenter server system, and its settings are transferred to all that hosts are associated with the distributed switch. And distributed port group define how connection is made through the distributed switch to the network. Okay, so next slide, we are going to observe the difference between standard switch and virtual switch. So if you see in this slide, we can see the standard and distributed switches shared features. Shared features means these all features are applicable in both standard switch and distributed switch. So standard and distributed switches have several features in common. So one is layer 2 switch. So layer 2 means normally OSI layers, we have a 7 OSI layers. Our vSwitch is considered as a layer 2 switch. So layer 2 switch role is available in vSwitch as well as distributed switch. And VLAN also we can create, and that VLAN tags, the default standard code for VLAN tagging is 802.1q. This is a standard tagging code, and it will support for IP version 6, and it will support for the NIC teaming, and it will also support for a outbound traffic shaping. We know traffic shaping is also one of the standard switch level policy. Same policy applicable in distributed switch as well. And a distributed switch provides centralized management and monitoring for the network configuration of all ESXi hosts that are associated with the switch. So this is important point. Now we're going to observe what are the features which is not available in standard switch but only available in distributed switch now. So additional features of distributed switches. See here, I haven't put any option in that this standard switch. That means it's not applicable. It's applicable only for the DV switch. So DV switch, there are all the additional features. Okay, we have a inbound traffic shaping and virtual machine network level. We can do the port block. We can block the port or we can allow the port. That feature is available in distributed switch. And private VLAN, as discussed, private VLANs are also configured, and load based teaming also possible, but it's not a NIC teaming, it's a load based teaming. and the data center level management only in a distributed switch. And as we discussed, vMotion can migrate the virtual machine of virtual network state without shared storage. Also, we can do the vMotion migration at virtual network state. Okay, and per port policy settings, like in our storage, we have storage policies for VM level, but in the DV switch level, per port also we can apply the policy settings. And port state monitoring of network statistics, it is also possible, and network flow monitoring, port mirroring. And the main purpose of DV switch is it is accessible to NSXT port group. It's always compatible for the NSXT as well. And the distributed switches include several features that are not part of the standard switches. So these all features not applicable in a standard switch. Okay, now I'll going to explain a few key uh, feature items like NetFlow, port mirroring, and private VLAN. I will try to explain one by one. Once we are familiar with all these features, we can start practicing the DV switch creation in our lab. Okay, so here let's try to understand the important point, private VLAN. So private VLAN in simple terms, normally VLAN means within one network, we are grouping of multiple networks is nothing but a virtual LAN. But again, within the virtual VLAN, if you want to isolate some network or if you want to isolate some systems, the concept is private VLAN. Isolate means separate. That network should not be visible to the external world, either internal world or external world. That concept is called private VLAN. So private VLAN, I will explain from this slide. It is used to solve VLAN ID limitations by adding a further segmentation. So segmentation means division. So if you want to divide VLAN into again some more divisions, we can go for a private VLAN concept of the logical broadcast domain into multiple smaller broadcast subdomains. Okay, to use the private VLANs between the host and rest of physical network, the physical switch connected to the host needs to be private VLAN capable. This is the important point. Even if you want to configure private VLAN, our DV switch is compatible to configure private VLAN. But our physical network also, we need to contact our network team whether our physical switches have a private VLAN capability or not. Okay, we need, that is important point. If we have physical network also private VLAN capable, then only we can enable this feature, or else we cannot enable the private VLAN feature. So configure with VLAN IDs being used by ESX for the private VLAN functionality. So for physical switches means normally in our real-time scenarios, our networking team will take care of the physical switch management. So within our physical switch also using the dynamic MAC means media access control or physical address plus VLAN ID based learning. So usually our physical switches, it will always maintain our ESXi host MAC and VLAN IDs. All corresponding private VLAN IDs must be first entered into the switches VLAN database. That means within our physical switches also, our network team has to register our private VLAN ID details first. Then only we can start configuring in our DV switch level. And eventually private VLAN allows a separation of traffic within a single VLAN. This is the our final end goal. Okay, and if we talk about some more additional points on private VLAN, let's try to understand from this table. Again, private VLAN, there will be a two types of private VLAN. We can divide the private VLAN into two subdivisions. One is primary VLAN ID, another one is secondary VLAN ID. And remember that primary VLAN ID is always the same. We cannot change the primary VLAN ID. And the secondary VLAN ID, again, we have a three types of VLAN types. One is promiscuous, isolated, community. So promiscuous is always equivalent to the primary VLAN ID, and isolated one is, it's a this, to achieve this isolated only they divided into two types, because we our objective is we should be separated from the VLAN network, but we require a communication. So that is the reason they subdivided the two VLAN IDs, primary and secondary. Within the secondary VLAN ID, we have a three types. Promiscuous means it's equivalent to primary VLAN ID, and isolated is a different number. This 12 is like a just logical number only, any number we can use. And community means it will communicate to the nearby promiscuous mode and it won't communicate to the isolated. That is a purpose of isolate and communicate. This VLAN types I will try to explain from the next slide as well. This is the one of the high level diagram for private VLAN. Let's say if you talk about the ESXi host, our ESXi host also require a communication to physical switch. But within our ESXi host, if you want to implement a private VLAN ID concept, log into the vCenter server, you can enable a private VLAN ID at DV switch level. When you add a private VLAN ID, within the primary VLAN ID, we have a secondary private VLANs. So secondary VLANs means you can configure three secondary VLANs. So if you see in this diagram, we have three secondary VLAN ID numbers, 102, 101, and 103. So 102, 101, 103, I divided into three secondary VLANs. So VLAN type isolated, promiscuous, community. So promiscuous means it's always communicate from promiscuous mode network to isolate, promiscuous mode network to community. That is the benefit of promiscuous mode. So I highlighted with green color. Suppose if I see the community, community means it will communicate only within this community, but it will not again. The benefit of community is the name itself, it says community. Community means within their community it will communicate. Again, it will also communicate to the promiscuous mode, but it won't communicate to the isolate. But isolated network main purpose is it's always won't communicate within the isolated network, within the community, but only facility of isolated network is it will communicate to promiscuous mode. Okay, so this whatever we discussed in this diagram, I will provide the description in the next slide. This is an important point because some of the interviews or VMware VCP exams, you'll expect at least one or two bits from this point, private VLAN and DV switch. Okay, that's why I'm trying to highlight this point. Private VLAN, a regular VLAN is a single broadcast domain. So normally every VLAN is a single broadcast domain. While private VLAN partitions, so again we partition one broadcast domain into multiple smaller broadcast domains. That is the private VLAN. So we can configure private VLAN in the vSphere environment. So how many types we can configure is promiscuous, community, isolated. So three options are available. I will show you the lab for this, how to configure also, but we cannot do the test because if we want to do a test, we must and should have a physical switch is enabled with a private VLAN, or else we cannot do a actual live test. But I will show you the options how to configure these three VLAN types, private VLAN types. One is promiscuous mode is always acts as a primary VLAN, and within the secondary VLAN, we have a community and isolated. So promiscuous mode, as I mentioned, it is mainly for first one create as a default, and the secondary one is mainly we can use for a web server and DB servers, and isolated one we can use for a mail server, FTP server, and IP storage traffics. Okay, and later you can just go through these points, whatever we discussed in this diagram, the same communication options I've written in the descriptive format. Okay, so let's move on to the next slide is for a private VLAN use cases. In which scenario will use the private VLAN? So private VLAN normally it's not only private VLAN use case. Even if anyone asks for vDS use cases, you can explain our previous all the features. Also consider as a use case, and specifically for private VLAN use case are these three use cases. So use case means what is the benefit of using a private VLAN? So let's try to understand the three main benefits. The one is by default there are 4096 VLANs are available every switch level. So only we can create maximum this VLANs only. If your environment is large enough, okay, large enough, where you need to more than 4096 VLAN. Suppose I want to create more than 4096 VLAN. During that scenario, if you want to divide your VLAN to multiple smaller groups, then you can go for a solution is PVLAN will be the solution. Okay, with PVLAN, you can subdivide one VLAN into multiple sub. Multiple sub means secondary private VLANs. Okay, clear? And the second point is use case two. When can we can use private VLAN for security purpose? This is also one main reason. Okay, what I mean by security here is DMZ. DMZ means demilitarized zone. In demilitarized zone, servers need to be available for external networks and possibly for internal network as well, but rarely needs to communicate with the other server. So we don't want communicate to the other servers. During that scenario, we'll go with a private VLAN configuration. And the third scenario is if you have a limited amount of uplinks, let's say I do not have much uplinks. Uplink means physical network cards in our ESXi host, and you want to use multiple VLAN because our physical network cards are limited, but you want to use a multiple VLAN to logically isolate. So if you want to logically isolate or separate also the virtual machine traffic, then private VLAN will be the solution. Okay, this is the three scenarios why we can go for a private VLAN concept. Okay, so next slide, I'm going to explain the another feature of vSwitch, that is LACP support. LACP means link aggregation control protocol. As I mentioned, this is our high level vSwitch diagram. If you refer the highlighted orange color, the purpose of link aggregation control protocol is at a time we can group the ports, the same grouping port we can link to the physical network to ESX network and ESX network to DV switch level also. So if you see here, link aggregation group 0, link aggregation group 1, 0. And again, within the host level, you can create a multiple link aggregation groups, link aggregation group 0, link aggregation group 1. So multiple groups you can connect in the physical network. That means the same ports I want to communicate through virtual layer as well as physical layer. During that scenario, you can enable a LACP protocol. Okay, so that is only the importance of grouping of dedicated ports on the physical layer and the virtual layer. At DV switch layer, you can use a LACP. Okay, the same points I explained in the description. With enhanced link aggregation control protocol support on a virtual DV switch, we can connect ESXi host to physical switches by using dynamic link aggregation. So we can segregate. It's also not limited to 2 ports. You can use a more ports also. We can create multiple link aggregation groups. So for our easy understanding in this diagram, I took here 2 groups, but you can create a multiple groups also on a distributed switch to aggregation the bandwidth of physical NICs on ESXi hosts that are connected to LACP port channel. So this is one port channel, this is another port channel. And we can configure LAG. LAG means link aggregation group with the 2 or more ports. See here we have 2 ports, but you can configure more ports also and connect to physical NICs to the ports. So link aggregation control protocol allows us to aggregate. Aggregate means combined with both VM NICs together into the one logical link. So this entire link, it will act as a one link only, one channel. And LACP provides a huge list of balancing methods. The benefit of LACP, why we need to use this feature is we will get a 3 benefits. One is network IO control. So always input and output control will be there, and also health check we can do, and we can also support for a port mirroring. That means this port is mirrored here, and we can capture the entire traffic without disturbing the production line. We can capture the traffic from mirrored port. Okay, that is also the benefit of LACP. Okay, and we'll talk about some more in detail of what is the use of port mirroring now. The port mirroring, as we discussed, port mirroring allows us to mirror a distributed port's traffic to other distributed port or specific, specific physical switch port. And port mirroring is used on a switch to send copy of bits. So mirror means it's a duplicate or copy of packets seen on one switch port on entire VLAN to a monitoring connection to another switch port. The port mirroring is used mainly for analyze and debug data or diagnose errors on a network. Suppose sometimes we didn't find there will be some network intermittent disconnections. Intermittent disconnection means our server is always up, but all of the sudden every 10 minutes once you are getting a request to timed out. During that scenario, if you want to identify that minimum intermittent disconnection issues, during that scenario will enable the port mirroring. Even when you enable the port mirroring also, we are not disturbing the production port. We are created a duplicate port. On the duplicate port, we can do we can analyze the logs, and we can do the capture the all the packet traffic. That is the purpose of port mirroring. Okay, so hope you understand the DV switch concept. Now we're going to start the DV switch lab. So within the DV switch lab, we have a 5 steps here. So first one is create a distributed vSwitch. And when we create a distributed switch, by default we'll get one default port group, and later you can create a multiple port group. That is our step one. And the second step is, once we create the DV switch, we can try to add the ESXi host. So whatever the host available in our vCenter, we can add the ESXi host to vCenter. And the third point, observe our DV switch configuration information. So we can verify what is the configuration, and then we can assign a NIC cards mainly for redundance on DV switch level. And the fourth point, migrate the virtual machine from vSwitch port group to DV switch. Suppose your virtual machines are running in a virtual switch port group level. If you want to migrate the vSwitch network from vSwitch to DV switch also, we can migrate and move the remaining NICs. Like if you have a VM kernel NIC cards, also you can move it to the DV switch. And if you don't want to use a virtual switch in future, you can clean up or remove anything, clean up the VSSS. VSS means vSphere standard switch. So normally most of the real-time scenario during the initial ESXi host setup, we use a virtual switch. Once we add the host to distributed virtual switch, we no need to use a vSwitch mechanism, because vSwitch is always a manual configuration. When you use a DV switch, is the benefit is it's always one-time configuration. Even if you have 100 hosts, 300 hosts, or more than 200 hosts, until the 2000 host also, the configuration is very quick configuration, one time setup only. So that's why most of the time during the initial time we'll configure vSwitch. When we add the host to the vCenter server, adding to the DV switch, we no need to use a vSwitch concept. We can just clean up, remove, or leave it as it is. Okay, that is a lab we are going to do now. Let me log into the lab system. Okay, so I just log into our vCenter server. Within our vCenter server, we have a 3 ESXi host. So we know this is the topology diagram for virtual switch. Today we can observe the topology diagram for DV switch as well. And if I select the ESX host 2, we have only one virtual switch, and there will be no DV switch. Even ESX3 also no DV switch. Even if you want to see the DV switch configuration details, we have to go to the networking tab. In our networking tab only, we can see our vSwitch and DV switch scenarios. Suppose if I select the data center here, there is no DV switch here. Even if you go to the networks tab, we have a separate options for network. It is showing the network port group is VM network port group. There is a tab for distributed switches. So if I click on distribute switch tab, it is showing us no items found. So we haven't created any DV switch here. So if you have DV switch only, we'll get the DV port group, uplink port groups, and network folders. At present, all are showing as empty. Now we are going to start the lab for the DV switch creation. So as per our notes, the first point is create a distributed switch. So we'll observe the distributed switch creation. So distributed switch creation is very simple. Log into the vCenter server, go to the host and cluster, select the data center, right click. You can see the option for distributed switch. So when you select the distributed switch, you can choose new distributed switch. This is the one method to create. And another method is select the data center, go to the networking tab, and go to the distributed switch tab. Within this tab also, actions, you can see the same option. So either you can right click this data center and create the option, or go to the data center, right pan, distributed switch tab, actions, distributed switch, new distributed switch. Any method we can create. Okay. So when I select the DV switch, by default it is showing us name as a D switch. D switch means distributed switch. If you want to set any different name also, we can set the namings. Let's say I'm just putting the name as a production DV switch. So production DS. Production DS means production distributed switch. Uh, just for our easy understanding, I'm just putting the name as a DV switch 01. So distributed switch 01, and our data center name is production data center 1. Click on next. While creation of distributed switch, we have a multiple versions. Let's say even if you want to create the old version of DV switch also, this option will use normally in your environment. If you have any ESXi old version, during that scenario, you'll choose the old version. If your environment is still running with any ESXi host 6.7 version, that time you can create this switch. If your environment of all the hosts are running with 7.0, better you can go with a latest version. Okay, when you go with the latest version, it is showing us features per version. You can get the all these features. See, just now we discussed, when you use a DV switch latest version, there will be multiple features. One of the feature is LACP. LACP means link aggregation control protocol, and it will also supported for a NSX distributed port group and MAC learning. MAC means physical address learning, and it's not a iPhone Mac. It's like a MAC address, media access control address learning, and also port mirroring. These are all the enhancement, and also NVMe over TCP. This is also feature available in 7.03. Similarly, if you select the old version, there will be a still the same features applicable. All versions have a same functionality of features. Okay, now the only difference of latest version of DV Switch 7 is it supported only for 7 version or later version. But this DV Switch will not support for a old version of ESXi host. Okay, that is only the difference in versions. Now click on next, and default uplinks is selected as a 4 uplinks. Even if you want to increase the more uplinks also, we can increase the more uplinks. So I'm just leaving the default uplinks. And the network output control, let's leave it default enable state, and the default port group also it's creating. If you don't want port group, just uncheck. If you want the default port group, you can enable the port group. Even our switch name we are creating as a production. So if you want to rename the default port group also, you can rename. Let's say I am renaming as a prod D port group. D port group means distributed port group. Okay. Now click on next. So here, if you read the summary option, it says that our DV switch is going to create production DV switch, distributed switch 1, and our distributed switch version. We have a uplink ports for IO control enable, and there is a one suggestion. So suggested next action. What is the suggested next action is new distributed port group, add managed host. These actions will be available in the action menu of new distributed switch. See, we in the back screen, if you see, we selected from same tab distributed actions only. Even they are also recommending the next time if you want to add the host or want to create a new port group, you can use this option action of the new distributed switch menu. Okay, so now click on finish. When I click on finish, you can just monitor the recent task. In the recent task, add distributed port group and create distributed switch task is completed. So if you see in our networking tab, you can see the distributed switch. Okay. Suppose if I go to the host and clusters, in our host and clusters, we cannot see the view for distributed switch view. We can see distributed switch view only from the networking tab. When I select the networking tab under data center, you can see vSwitch VM network port group name, and also you can see the DV switch. So if I select DV switch, this is icon for a production distributed switch icon. Okay, and we have a default port group and we have a default uplink. Uplink is nothing but a physical NIC cards, but currently there is no physical NIC cards. We can add the uplinks also now. Okay, so the first option we observe that how to create a distributed switch. So the first point is clear, and the port group also it's created default port group. I will show you how to create additional port groups also. Additional port group creation is pretty simple. Just right click the host. You can go to the distributed port group, new port group. You can click on here. You can create a port group. Suppose I want to create a port group for some different VLAN port group or else production applications, right? Let's say I created production DV port group. Now I'm creating for a web server port group. Let's say all web servers comes under this port group. So I put the name as web port group. All web servers is created under this port group. While creation of port group, there is a additional options. Port binding, you can use static or no binding. We'll use the default option. And port allocation. This port allocation, elastic and fixed. Normally the meaning of elastic is nothing but a flexible. So ports always it will allocate automatically when you select a elastic. When you select a fixed means the port number, whatever the ports we have, this number will be fixed. So no need to modify, just leave it default. Even there is an information button. When we click the information button, it clearly says that elastic port group automatically increase or decrease the number of ports as needed. So better we'll choose the option as elastic. No need to modify anything. Even in future, if we create more than 8 virtual machine, this allocation will automatically increase the port count. Okay. And VLAN type, we have a default option is none. If you want to assign any VLAN, we have an option to choose VLAN, enter the VLAN ID number, and we also have an option for VLAN trunking. VLAN trunking is for a grouping of multiple VLANs. We call it as VLAN trunking, and there is advanced feature private VLAN. Today we discussed about the private VLAN. It says that private VLAN is not configured for the distributors. First, we need to enable this feature, then only we can configure the private VLANs. So currently we do not have any VLAN switches in our home lab. So I'm just leaving as a none. But in the real time scenario, if you want to assign the VLAN number, we can get the VLAN ID numbers from our networking team. So sometimes they will give VLAN ID number, or sometimes they will give the VLAN trunk range. The entire range you can enter here. Okay. So currently we do not have the VLAN information. Just leave it as none, and there will be a customized default policies. So we already know vSwitch have a default policies, security, traffic shaping, and these all the policies will come now. When I enable this option, in the left side, you will find security, traffic shaping, teaming, and failover. Suppose if I uncheck this option, there will be no features, but the features will applicable automatically from the DV switch to port group. Okay, so either you can enable or disable the features will definitely, the policies will come automatically from master DV switch. Okay, so now click on next. We'll observe the policies again. The policy same as vSwitch. We have promiscuous MAC address, port transmit. Let's leave it as default option. And the traffic shaping also, we have two type of traffics, but the ingress and the egress is like a incoming and outgoing. In our previous vSwitch, we don't have these two features. This is the feature available only in a distributed virtual switch. Click on next. And the teaming and failover, even if you want to team and failover, the options are same like vSwitch: load balancing, network failover detection, notify switches, and failback option. So here also you can just go with a default options. Click on next. See here you can see the monitoring option. See this monitoring option at the DV port group level, we do not have this facility in a vSwitch. Only this option in a DV switch level port group. And net flow, default net flow is disabled. If you want to enable, you can enable the net flow. Okay, so click on next. Net flow is for a, see in the above heading, if you see here, net flow mainly for monitoring purpose, network flow monitoring. And miscellaneous, if you want to block any of the ports, you can block the ports, or you can use a default option for the time being. Click on next. So this is the summary view. We are going to create a port group as a WebDB port group. Static binding, number of ports 8. Port allocation is elastic. Elastic means even in future it will increase automatically. Okay, now click on finish. So when I click on finish, under DV switch distributed switch 01, the default port group is production port group. I just know we created a web port group. Even if you want to create another port group also, same option, select the distributed switch, right click, you can go to the distributed port group and choose new distributed port group. Let's say now I want to create a port group for app servers. Let's say app DB. All the application servers I want to map to this port group. Click on next and use the default options, default policies. Click on next. I'm just going a bit faster now because we already observed these features. Finish. So the web port group also created. Same way, if you want to create one more port group for database servers, select DB. Port group name you can mention as a DB. Why I create a web app DB means most of the real-time scenarios, all applications are three-tier application. Three-tier means every application, let's say our website, any website, company website also require a one web server that is under web port group, and that website, all the application is running, website related application is under app DB, and the website data comes under the DB port group. So three-tier architecture means we require minimally three servers: one web server, one app server, one database server. So each server we configure a different port group. Okay, so now we are familiar for DV switch creation and port group creation. Even if you want to create additional DV switches also, go to the actions, distribute here. You can choose, we are under the this one, not recommend to select here. We need to select the data center, distributed switch. See production DV switch is here. Now go to the actions. You can choose the option distributed switch, new distributed switch. So I'm going to create another DV switch again. So another DV switch, I put the name as a test and dev. So normally in the real time also, we'll maintain multiple DV switches, one DV switch for production environment and one DV switch for test and development. So creating another DV switch now. So default options, click on finish. So another DV switch is created. And the default it comes with a one DV port group and uplinks. Uplinks also by default it will comes with a 4 uplinks. Let's see our point. So we are familiar with the first point now, DV switch creation and creating of port groups. Now we'll talk about the second point. Second point is add the ESXi host to new DV switch. So how we can add the distributed switch host is, again go to the vCenter server, log into the uh, vCenter using vSphere client, go to the networking tab and select your production distributed switch, and right side you can see the option for actions. When you select the actions, you can see the option to port group creation. This is the one, but to add the host, you can see the option here, add and manage host. So you can click this option. See, there is a three options. One option is add host and another option is manage host networking. If you want to do any changes on the existing host networking, you can go for second option. And third option, if you want to remove any host from the DV switch, you can choose the third option. But present in our ESXi host, if I select the DV switch, go to the host tab, there is no host. Okay, now we are going to add the host. Even virtual machines also, no virtual machine, no networks. Only default uplinks are port groups and uplinks are created, but there is no virtual machine. Virtual machines is showing as 0. Okay, now we are going to add the host here. Okay, select the DV switch, go to the actions tab, and now you can choose the option add and manage host. So select the relevant option is add host, click on next. When we click on next, you will find whatever the host we have in our vCenter, all the hosts are applicable here. It will shows here. So now you can add the host one by one, or you can select all at one shot. Okay, so I selected all hosts at one time. So ESX1, 2, and 3. Now click on next. Okay, so even while adding the ESX host itself, you will get the your ESXi host physical adapters. So you can add all physical NICs at a time, or you can add the adapters per host wise. So even here adapters, assigned adapters are 0. But before adding the adapters, if you want to choose, you can just select here, there will be a adapters. But let me cancel this. We'll quickly verify how many network adapters are available on our 3 ESXi host. So let me cancel here. Go to our workstation. Let's quickly verify our ESX host running with how many NIC cards. Oh, ESX host running with 5 NIC cards. And even the second ESX host, how many NIC card? We have 5 NIC cards. And ESX3, right click settings. We can see ESX host running with 5 NIC cards. Again, the same NIC cards you can also verify from vCenter level. Select the ESXi host, go to the configuration tab and select the physical adapters. You can see NIC cards. So if you see here, only VM NIC 0 is assigned for vSwitch 0 and the remaining 1 to 4 is free because it's not connected to any switch. And same way ESX2. Oh, here VM NIC 0, VM NIC 1 is assigned, but remaining NICs are free. And ESX3 also 0, 1 is added, 3 NICs are free. Okay, for our easy understanding, we start using DV switch from VM NIC 2, 3. Okay, here also we can use 2, 3. Here also we can use 2, 3. So if you want to use the same uplinks on the DV switch level, let's go back to networking tab, select the DV switch, go to the actions, and you can choose add managed host, add host. While adding the host, select the ESXi host, click on next. Now we have an idea which NIC card we can choose. Okay, so we can plan to choose 3 hosts. We can plan to choose the VM NIC 2. So choose that NIC card. So choose the uplink as uplink 1 is dedicated for VM NIC 0, VM NIC 1, VM NIC 2. So that means uplink 3. And even VM NIC 3. VM NIC 3 means you can choose uplink 4. Okay. So here because VM NIC starts the letter is 0, but our network cards are 1, 2, 3, 4. So that's why 2 means uplink 3, 3 means 4. Okay, so for the time being, I'm just added here 2 NIC cards per host. Okay, so this switch is added. this NIC card. Now click on next. Even if you want to verify from adapters per host also, you can verify from here. So it is not showing. Once we click finish only, we can see the adapter count. Okay. So now click on next. One or more hosts have no assigned physical adapters. Virtual machines running on this will encounter a network problems. Okay, it's fine. Let me cancel. So 3 hosts connect. Sorry, let me connect again. Okay, NIC cards are connected. Click on next. So 3 hosts are connected with VM kernels are running on the existing host. We no need to do any changes at present. Later, if you want to do any VM kernel level changes, we can do. Now click on next and migrate VM networking. Even if you want to migrate the virtual machine from VM network to vSwitch and distributed switch networking, you can migrate here. At present, no VMs are showing here. So leave it as it is. Click on next. So what is the task we are going to achieve now is we are going to add a 3 Esxi host, and each host I selected here 2 adapters. So total adapters are 3 into 2, 6 adapters we are going to add. Now click on finish. So when we click finish in the recent task, you can find our task. See, update network configuration completed for ESX1, 2 and 3. Okay. So now if you select the same distributed switch, right side, if you go to the host tab, you can see that 3 hosts are added. Okay. And if you go to the virtual machine tab, currently no virtual machines are added under the DV switch. I will show you how to migrate from vSwitch network to DV switch networking. And the networks also, we have port groups are ready and VLANs no VLAN, but the VMs also no, but all the default options are showing here. Let's go back to our lab information. See, the second point is also completed. We observe how to add the Esxi host to new DV switch. Same way in future, if you add one more host also, same way we can add. Now let's talk about the item number 3. So observe our distributed switch configuration and assign redundant NICs on DV switch. Even redundant NIC during the DV switch adding the host itself, we added a additional NIC cards. Okay. Now we can observe the migrate the virtual machine from vSwitch to DV switch. So log into vCenter. If you want to migrate virtual machine from vSwitch to DV switch, let's choose any one VM. For example, this VM name is NFS test VM. This test VM is Windows 2022 and verify the VM hardware network. This network is connected to VM network. So if you want to migrate this VM to DV switch networking, there are multiple options. Let me show you the all options now. Suppose if I right click here, virtual machine, go to the edit settings. In our virtual machine edit settings, you can see the VM network. Just to select the drop down menu, click on browse. When you click on browse, not only our VM network, you can see our distributed port groups, app D port group. D port group means distributed port group, and this is connected to distributed switch 1. And you can choose any port group right here. This is the one method of selecting migrating the VM from vSwitch to DV switch. This is the one method. Suppose if I select here app network, click on OK and click on OK. So in the recent task, you can see update confirmation. And now the virtual machine, when you go to the VM summary tab, you can see VM is connected to DV port group. Okay. So if you is connected to app port group, again, go to the networking tab, select the distributed switch. We can observe the how many VMs are running here. Under DV switch, 3 hosts are added and virtual machine, 1 virtual machine is connected. And even in the, if you see in the network tab, there is 1 virtual machine count. Earlier the count is 0. Now it is showing as 1 virtual machine. This is one method of migrating the virtual machine from vSwitch to DV switch. Let me show you the another method. Let's say I want to change back to VM network. If you want to change back to VM network again, right click the VM, go to the edit settings. Now I'm again changing the network to VM network. VM network means virtual switch networking, standard virtual switch networking. Click on OK. So when you click on OK, see here, it is showing as standard switch networking. Now I will show you the another method of migrating. How we can do the another migrating is go to the networking tab. Here, right click the DV switch. You can see the option for distributed port group. You can see a migrate option. Either you can see from here or you can see directly on the VM network, right click here, migrate option. Sorry, we have to select the source is standard switch VM network port group. Right click here, there is option migrate virtual machines to another network. So you can choose this option. This is also another way of migrating, but the purpose of this network is you can not only migrating one VM, you can migrate multiple VMs. See, if you see here, option is migrate virtual machines, not only one VM. At a time we can migrate multiple VMs. So before migrating the multiple VM, let me create another test VM. Right click the host, create new virtual machine, create new VM. Let's say I'm going to create another test VM. Let's say test VM 02 and choose the any one ESXi host. ESX1, click on next, choose the data store, click on next, next. These options are we are familiar, and we are choosing the network as default standard network, vSwitch network. It's showing some error message. So let me choose the another data store. Maybe the vSAN data store having some issue. Let's say ESX3, and we have two data stores here. Let me choose the NFS data store. Click on next, finish. So now we are creating a VM creation is completed and our virtual machine, new virtual machine name is new virtual machine. Even if you want to rename it to another name, we can rename. Select rename, and I'm renaming as a test VM02. So click on OK. So we created a test VM01, test VM02. Another two VMs are inaccessible state. Okay, I will check later. So now we'll focus on the test VM01, test VM02. If you want to migrate these two VMs, currently VM2 also connected to vSwitch network. If you want to migrate these two VMs, go to the networking tab. Not only two VM, even if you have more than two, like 100 VMs also, we can migrate one within single option. We can migrate. Right click the VM network, go to the migrate VMs. So here you can choose the destination network. Let's say I want to migrate this as a test VM. So test VM means, let's say very less critical one we can choose. Instead of production port group, I'm choosing a normal port group, D port group I'm selecting. D means distributed port group. This is for a test and dev. Or else within the production switch, if you want to migrate to app also can. Let's say I'm choosing a app. Click on OK. So port group selection is completed. Click on next. See here how many VMs we want to migrate. It is showing the option as select virtual machines to migrate. You can select either one VM or multiple VMs you can select. I'm just showing the test as a 2 VM. It's not limited to 2, even more than 100 VMs also you can select this option to migrate. Okay, so now click on next, click on finish. So when we click on finish, you can see our select our production switch and production distributed switch, go to the VMs tab. You can see two virtual machines are migrated here. And for this activity, we don't require any network interruption. Within fraction of seconds, it will migrate from source to destination. But only condition is whatever the network we are maintaining on vSwitch, the same VLAN, same network should be available on the distributed switch. That is the only the condition. Okay, but in our lab, we all network is same network. We are using a 192.160.10 series, but in the production scenario, there will be a different VLANs. So during that time, we should be verify cautiously whether VLANs or everything is correct. Then only you can migrate to the respective distributed port group. Okay. So in our test lab, no issues. All are running in a same network. Okay. So we observe how to migrate the virtual machines from vSwitch port group to dvSwitch port group. And next option, move the remaining NICs. Even if you want to move your NIC cards also, we can move the NIC cards. NIC card option we observed in our adding the host scenario. Suppose in future, if you want to add any NIC card to our distributed switch, go to the configuration tab, and under the configuration tab, or else here we can add, there is another method is go to the host and clusters, select the ESXi host, and first to verify how many NIC cards are free. Let's say here, if you see here, we can observe the how many NIC cards we have a VM NIC 0 to 4. 5 NIC cards are available. 2 NIC cards are already added to production DV switch. Suppose I want to add another NIC to the another vSwitch. How we can add is, you can go to the virtual switches tab. Within the virtual switch tab, you can see distributed switch 0, and you can see here you can see the topology for a vSwitch. And suppose if I select the ESX3 also, you can see the clear vSwitch view. Distributed switch, production vSwitch 0. If I select this test network, you will see the connection, how it is communication to vSwitch. This is a distributed switch. Okay. And within this distributed switch, if you want to add a additional physical NIC cards, you can click on manage physical NIC card. Whatever the NIC card is available, you can just select and add. Okay, this is one method. Or else another method is, let me add for another DV switch. Another method, let me show manage adapters. Click on plus sign. When we click on plus sign, VMNIC4 is available. So let's choose the VMNIC4. Click on OK. Click on OK. See, now if I expand here, you can see how many NIC cards are added. VMNIC3 is added, VMNIC2 is added, and any other, yeah, from esx3demolab.com, 3 NIC cards are added to this production DV switch. Same way, if you want to add from another host, select the host, and here first observe how many NIC cards are added. We have only 2 NIC cards are added. You can verify from topology diagram, or you can go to the physical adapters. If you see here, 2 NIC cards are added to vSwitch 0, 2 NIC cards are added to DV switch, and 1 NIC card is free. This 4 NIC card, if you want to add, the only option is go to the virtual switches tab. Here virtual switches means it consists of both switches, standard switch and distributed switch. Okay, so here under the DV switch, you can click on manage physical adapters, and you can choose the plus sign. Click on plus sign. You can find VMNIC4. Click on OK. And even while adding the NIC card, it will automatically adding to the uplink one. You can modify either move up and down also can possible. Okay, and click on OK. When I click on OK, you can see how many NIC cards are added. See, from the NFS test VM1, we have a 3 NIC connections. One is for uplink one, see ESX2 network, ESX2 network, and also ESX. So that means totally 3 physical NIC cards are added. And same way, select the ESX1. ESX1 also similarly, we can add a additional NIC cards. Click on plus sign, choose VMNIC4, click on OK, click on OK. Currently there is no VMs, but the NIC cards we can observe here. So NIC cards are added. Okay, so same information if you can see from a DV switch here. When you select the DV switch, right side, under this DV switch, we have 3 SXA host connection and 2 virtual machines are running, and networks also we can see here. 2 virtual machines running, 8 ports are using. Okay, all in. Even uplink port group you can find from here. See how many ports are added. Each host we added here 3 links. So 3 all the uplink ports are you can find from here. Okay, and the vlink maximum VLANs we can add 4094, or we can say 4096. If you want to create more than 4096 port group, we should go for a private VLAN concept. So private VLAN concept, if you want to do here, select the distributed switch, go to the configuration tab. Under configuration tab, you can see the DV switch features. See, just now we discussed the topology. See, this topology will show you all the high level hierarchy. Suppose let me minimize the recent task. See here, you can see within the single screen, you can find all the port group information and DV switch information. Suppose if I want to expand any VM, select VM, click on here, you will find the connectivity. And even select the second VM, you will find the connectivity status. And other port group, currently no virtual machines. This is the topology diagram for our distributed switch. Okay, and we also have a concept of link aggregation protocol. So currently we haven't enabled, but link aggregation protocol we can enable from a DV switch configuration tab. This one, in order to do this one, we should also do initial configuration at physical switch level, and then we can do it in the virtual switch level. Okay, and private VLAN, even private VLAN also we can configure here, but private VLAN also condition is initially we should configure at the physical switch level. I will show you the options in the private VLAN. Excuse me. Click on edit. See, in our private VLAN, as I mentioned, private VLAN have a 2 types of private VLAN. Primary VLAN, secondary VLAN. We'll verify the options here. When we select the private VLAN, click on add. So let's say default private VLAN ID is 1. Suppose I just choose the number as 100 for our testing purpose. Whenever we create a private VLAN ID 100, by default, the secondary VLAN also will create the default secondary VLAN is promiscuous mode. So now just click on OK. When I click on OK, so you can see primary VLAN ID 100, secondary VLAN also equivalent to primary, and the VLAN type is promiscuous. Suppose if I want to add one more secondary VLAN under the same primary VLAN ID, just click on edit, select the primary VLAN ID, and here right side you can see a primary VLAN ID is always one, and under one primary we can create multiple secondary. Like suppose in our previous diagram, if you see, I mentioned here primary VLAN is 80. Within one primary VLAN, we can create multiple secondary and different type of VLANs. So same lab I'm going to do now. Okay, so log into server, and within the 100 primary VLAN, one default is created. I'm adding one more. Click on add, and here instead of 100 VLAN, you can put any other number. Let's say I'm choosing 110, and it's a default selected as a community. And again add one more, and you can choose. I'm just choosing as 120, and 120 you can create as a community or you can create as a isolated type. Okay, and the community, you can always create multiple community also, that is no issues. So now click on OK. So when I click on OK, see you can see the table here, private VLAN table. Primary VLAN always same 100, and the secondary VLAN we can create multiple VLAN secondary VLANs, and VLAN type is multiple VLAN types: promiscuous, community, isolated, and community. Community also you can create multiple. The main purpose of private VLAN concept is isolated. Okay, in order to do this isolation, there will be a multiple options. Okay, this one only the table I explained in our slide 80, 80, 12, 22. Even if you want to maintain this number also, we can just create a primary VLAN. For example, if you want to create one more primary VLAN, click on add, and here you can choose the number as 80. When you click on 80, see by default it comes here. 80 promiscuous will create automatically, and I'm adding one more 80, or 12 we can add. 12, what is the option it is showing? 12 is isolated. So we can mention 12 and change the type to isolated. It is showing as always have only one isolated. So we can modify here, or else just select this, remove, select this, remove. And here we can put 12 and change it to isolated, and add one more, and one more is 22. 22 is community. So you can enter the value as 22 and change it to community. Click on OK. So when we click on OK, the VLAN is changed to 80, and the secondary is 12. 12 is dedicated for isolated, and the default to 80 is always promiscuous mode and community. Same like our this table I just created. Okay, but remember that this is only we can create private VLAN only in a requirement scenario, either security purpose, or you can create mainly for whenever we have a limited uplinks. To maintain a multiple VLANs, you can go for a private VLAN concept. Okay, but the real test, the purpose of VLAN is mainly for isolated. Okay, and now let's verify our lab slide. In our lab slide, we observe this point: migrate virtual machine to vSwitch to DV, and move the remaining NIC cards also we verified, and clean up the vSwitch. Suppose if you want to remove the switches, we know the option, right? So go to the data center. You can see the switches option, vSwitch option. vSwitch option we can find only in a individual host. Sorry. So go to the Esxi host. If your vSwitch is no virtual machines, you can just go to the action here, remove. This is the option to remove the standard switches. Okay. So this is the DV switch lab concepts. These are the main 5 labs for DV switch, and in addition, we also observe the features, DV switch features. DV switch features we can find from configure, select the DV switch, go to the configure tab, and we can see the features. Topology diagram, and LACP, link aggregation control protocol, and private VLAN we just verified, net flow, port mirroring, health checks and all we can find here. And one of the additional feature, if you want to take the backup also, we can find the options here. Options are, this is for upgrade, and if you want to edit any settings, settings option, and export configuration, there is one option to export, that is for a mainly for backup. Yeah, import and export options. Okay, so if you have any questions, let me know. That's it for today. If no questions, we can end the session here. Thanks for your time.
Thank you.
Yeah, thank you. Bye for now.